Hello everyone. Okay, so guys, let's wait for a few minutes so that the others can join and then we can start with the session. Okay, okay, just comment and let me know if my screen visible and you can see me. Hello Subin, I'm audible. Audible also, guys. Just confirm if I'm audible. Okay. Great. Also, guys, just remember, note that this session is going to be a little bit long because if you want to learn service mesh, it's kind of topic that you need to understand the basics also about Kubernetes, like internal communications. So that basic thing we are also going to understand, and then we can proceed. Okay. So let us get started now. So the thing is ki, this session for this the main component that we need to have is EKS cluster or any other kind of Kubernetes cluster, and I'm going to be using Terraform for creating the cluster. So let me, and because if I since I'm going to use Terraform, it's going to take quite long time to create. So quickly I'm going to start the process of creation, and then we can start understanding service mesh, and in backend our cluster will be getting created. Okay, so let me share my screen. Okay, I hope my screen is visible. So first thing that we can do is go on our AWS account, and here I'm going to create one server from where we are going to manage our cluster. So I'm creating Ubuntu machine type version 24.04, and instance type I'm going to be taking T2 medium, which is going to be more than enough for us. Then we are going taking the key pair. This is some key pair that we have already on our local. If not, you can create a new key pair, provide a name, make sure it's RSA kind, and format should be PEM. Okay. Security group, we can select the one that we have, the primary one, and storage I'm giving 25, and we can create this machine. So once this instance has been created, we can connect to this instance, and using MobiX term we can connect to it. Okay. Machine is going to be, username is going to be Ubuntu, and make sure that you are going to advanced SSH. Click on use private key and provide the path of the private key that is present. Okay, I click on OK, and we can try to confirm. Okay, so now machine is our like server machine has been connected. So from there, here we are going to create the EKS cluster, and as I say, using Terraform it's going to take quite long time. So for that purpose I'm creating it right now, so that while we are understanding service mesh, in backend our cluster will be created. Okay, so I will run the command sudo apt update. Okay, and next thing that I'm going to be doing, since we want to create the cluster from here itself, so we need to make sure that this VM has access to our AWS account so that it can create the cluster. Okay, for that what we need to do, we need to make sure we have installed AWS CLI. It's a CLI tool which is going to interact with AWS. Okay, so quickly I'm going to install this as well, and let's wait for this to complete. Once this is done, then we have to add the credentials. From where we can get the credentials, you can click on your profile name, security credentials, and here you can scroll down to access keys. Now I'm creating root access keys, which is for demo purpose. Okay, so you can click on create access key and you can create the access keys. So AWS CLI has been installed. Now I can execute command AWS configure to provide the credentials. So these credentials, once you create, you'll be able to download it on your local machine. Okay, so this is the access key which I have downloaded. I can provide that here. Then secret access key, same thing, I can select from here and I can provide here. Then we have to provide region name. Make sure that you are choosing the region that is nearest to you. For me it's going to be AP-South-1. Click enter and again click enter. So now we are connected. Final thing that we have to do is clone the Terraform repository that has the code to create the EKS cluster. So this is the repository. It is public, so you can utilize it as well. I'm going to clone it quickly, and once this is done, we are going to install Terraform. Let us go inside the repo and install Terraform. Okay. Okay, that is done. And now we can execute the command Terraform init, which is going to initialize. And after this is done, then we can run the final command to start creation of cluster. So let's wait for this as well. Okay, final command Terraform apply auto dash approve. It's going to create the cluster. Okay, and again, it's going to take quite some time. So meanwhile, this is getting created. What we can do, we can now understand the service mesh. Okay, so let me open OneNote where I can guide you. Okay, so now let us understand about service mesh, what exactly it is. So okay, let me explain the first agenda of the today's session. First, we are going to set up our EKS cluster. Secondly, we are going to be understanding the service mesh, and inside this we are also going to understand the Kubernetes pod communications. Okay, because this will be mandatory for us to learn in order to understand service mesh. Thirdly, we are going to set up the service mesh. Fourthly, we are going to deploy the application. And fifth, we are going to see different features of service mesh, how exactly it works. Okay, so these are the things that we are going to be focus on. Okay, so first thing, let us understand about the basic communication, how communication happens inside Kubernetes cluster. For example, let us say this is my Kubernetes cluster. Okay, this is my Kubernetes cluster, and there is one pod present. Let's call it as P1, and second pod present. Okay, P2. And let us say that they are currently in the same namespace. Let's call this namespace as N1. So if this pod needs to communicate with this pod, how they can communicate? First of all, one benefit is that they are in the same namespace, so they can communicate without any restriction. Secondly, if any pod needs to communicate with each other, they need to communicate using these services. So this pod has its own service S1, this pod has its own service S2. So now if pod 1 need to communicate with pod 2, the way that it's going to work, pod 1 is going to send the request to service 2, which is going to forward it to the pod 2. This is how communication will be happening. Okay, similarly, if pod 2 need to connect to pod 1, pod 2 is going to send the request to service 1 of pod 1, which is going to forward it to pod 1. Okay, basic understanding, I believe, like you might already know why we are using service, because it has the static IP. Okay, right. Now let us understand key. We understood the basic thing, ki how communication happens between pods, right? Next thing that you need to understand, ki when we talk about communication among, like let's say ki you have a microservice project deployed, right? So if you have microservice project deployed, there will be so many different microservices created, so many different pods created, and if communication need to happen, this is how they can communicate with each other if they are in the same namespace. Okay, but if we have not set up service mesh, what is going to happen? By default, like communication is allowed, and there is no proper way to, like, the communication that is going to happen internally in Kubernetes, it's happening in plain text. There is no encryption, nothing is there. Secondly, there is no way to monitor those traffic, whatever communication is happening, there is no way to monitor it properly. And there is no way for us to perform the traffic control. Like we cannot decide key, like if we have multiple pods of an specific microservice, so we cannot decide key out of, if one microservice has 3 pods, so we cannot decide, like automatically there is no option available that you can decide key, okay, on this pod only my traffic should be going. Okay, next thing, there is no option to set up retries. For example, you are sending a request to a specific pod, right, and you are getting error 503 timeout. So if you want to resolve this issue, you have to write code in your application source code, how to handle the timeout issues, right? This option is not available by default inside Kubernetes. Okay. So these are the problem statements that we have inside Kubernetes if you are not using service mesh. Okay. So now let us understand how exactly service mesh going to resolve this and what exactly is a service mesh. Okay. So firstly, the basic definition that we have about service mesh, what it is, it's a infra level component that is going to manage the communication and traffic inside Kubernetes cluster between different microservices. Talking about what benefit we get, because see, if you are not using service mesh, still the communication is happening inside cluster. But if you use service mesh, what exactly is the benefit that we get? Okay, so let me explain you. First thing, even if communication is happening inside the cluster, that communication is encrypted. Okay, that communication is encrypted. That means ki, uh, see, because when we set up our application, when we deploy, we use HTTPS, so that securely communication can happen, and like we use certificate for that. Similarly, if we use service mesh inside Kubernetes cluster, the communication between two pods, the pods bit of different microservices that happen, that is going to be encrypted using mTLS. mTLS means mutual TLS. Okay, that means ki if this pod, if this microservice need to connect with this, communication will be encrypted here and here, both the points. That is first benefit that we get with respect to service mesh. Secondly, you have complete control over traffic. That means let us say we have one microservice that has three pods, pod 1, pod 2, and pod 3, and they are going to be connected to the same service, right? So if we don't use uh, Adrisha, Basu, can we control via network policy? You can definitely control, but that is a different level of control. Like using network policy, we set up restrictions. But here, using service mesh, we can set up scenarios where key out of these three pods, certain percentage of traffic should be going to one pod, certain amount of traffic should be going to second pod, and certain amount of traffic should be going to third pod. Okay, so let's say we have these three pods and traffic is coming to on this microservice. So using service mesh, we can decide, or we can set up condition ki if there are 100 traffic coming, like 100 users are trying to access, so we can decide ki, okay, 50% of the traffic should be going to pod 1, 50% of traffic should be going to pod 3, and 0% here. That means we can have complete control, and this is quite useful when you are talking about uh, canary deployment, where we have to we have to deploy two versions, and we have to uh, increase the number of users that should be able to access the upgraded version. Okay, third thing that you get very easily when you use service mesh is the monitoring and logging. So basically, whatever traffic is going inside, like whatever communication is happening inside Kubernetes cluster among different microservices, that also can be monitored very easily. Okay, using Prometheus, Grafana, Kiali, we can monitor complete traffic, what exactly is happening, we can monitor those things very easily. Okay, this thing. Fourthly, generally when we don't use service mesh and we want our application to be accessible from external, what we do, we set up ingress controller, right? Ingress controller resource, those things we set up. And if we have multiple application, then we have to set up for each application we have to set up separately. But here you just have to like automatically one ingress of the Istio will be set up, and we can use it for multiple application. Few things we have to modify, but it can be utilized. And in reality, this version ingress of service mesh, when we implement it using Istio, it's much better, and it has so many advanced features when we talk about external control, external access to the application. Okay, so all these features, there are many other features also available, but these are some of the main ones. So all these features you get very easily inside a Kubernetes cluster when you use service mesh. Okay. One word you might have also seen, Istio. What exactly is Istio? So Istio is basically implementation of service mesh. Okay, service mesh, we have a proper concept available, but if you want to implement service mesh, you could use Istio. There are other things also available that can implement, but this is one of the most popular and most widely used, Istio. So Istio is what? It is implementation of service mesh. Okay. So in simple words, we can say that service mesh is what? It's a basically way to manage your traffic completely, set up like monitor the traffic and secure the traffic so that whatever communication is happening inside the Kubernetes cluster among different microservices, those are secured, those are monitored so that we have complete control. Okay. One more thing, I said key service mesh using Istio is also quite useful when you want to perform canary deployment strategy. How exactly does it work? So basically, let us say, first of all, let us understand what exactly is canary deployment. So in canary deployment, let us say that currently we have deployed our application, which is version 1. Currently it is running and it is accessible using service. Okay. So, and this is, let's say, this is uh, 2 pods running. Okay. 2 pods running, or we can say ki total 4 pods are running, which is of version 1. And if any user want to access the application, they put the URL and it points to these pods. Now I have a requirement that I want to upgrade my application, so I upgraded the application, created new Docker image, and now we create a new pod which is version 2. It is also going to be connected to the same service, but because see, if total 5 pods are available, then service is going to perform load balancing. Equivalent amount of traffic will be going to all the pods. But what we do using Istio, or there are other methods also to implement canary deployment, we can define the traffic percentage. For example, I'd say that key here only 20% of traffic should be going, here 80%. In canary, what happens, we say that we release the upgraded version to small group of people. Okay, so we upgrade, we said that key, okay, 20% of traffic should be going to version 2, and we pause the rollout for, let's say, key 2 days. In 2 days we will monitor, we will analyze ki how version 2 is behaving based on public response, public people who are able to access it, how exactly it's behaving. So once we have monitor, we change the weight, these are weights, so we change it to like this ki 50% and 50%. Okay, in that scenario, what is going to happen, there will be two v2 pods here and two v1 pods here. Okay, total 4 pods are available now, and 50% traffic is going. Again, we will pause, we will monitor it for 2 days. Okay, so this monitoring will be going on 2 days, where we have to again monitor and see how exactly it's behaving. And once everything is fine, then what we do, we forward the complete traffic 100%. And now here cutoff will be done, and here complete traffic will be going here only to version 1. And this is how canary deployment upgrades happen for applications. That also I'll be taking one live session for this also. Okay, so now we understood service mesh, and now we can implement it. Okay, for that, first of all, let me check. Okay, so here you can see that our EKS cluster has been set up, so we have to make sure we have access to it, and then uh, we can start implementing. Okay, but before that, I want to show you with a proper example how exactly and what exactly is the difference between the service mesh based cluster and without service mesh. Okay, so for that, I'm taking one example. This is a microservice based application, and I'm taking this example. So let me show you in detail and explain it. Okay, let us say that this is our application. This is a microservice application. You can see how many components are there. Product page, which is the home page, details, ratings, and reviews. Okay, so if we are not using service mesh, what is going to happen? Request come, it goes to product page, and from there the product page, which is also the home page of our application. So on home page, what information we get? We get the details from here, and we get the reviews, right? Reviews also, it can be with rating. Okay, you can see this. Now In here, these are pods actually. These things that you see, these are pods. Now here you see reviews version 1, version 2, version 3. Okay, there are three pods available for reviews, and all three pods are completely different. The version 1 pod in reviews, it's not going to show the ratings. Ratings means how many star have been received on the specific book. This is a book info application. Okay, when request goes to product page, it shows the details of the book and reviews of the book and ratings. Now here, let us say that traffic comes, some user is there, or user one, who goes on the home page. Home page means product page he went. Now from product page, traffic is supposed to go to two places: details and reviews. Okay, so on details it went, and on the home page we are able to see the details. Okay, second thing that we have is we need to see the reviews also. But for reviews we have three pods, and all three pods are of different version 1, version 2, version 3. In version 1 there won't be any rating, as you can see, because this pod is not at all connected to the ratings pod, while these two pods are connected to ratings pod. But these two pods also, which are going to show a star, they have a difference of colors. If the request goes to review version 2, it is going to show a black star rating. If the request goes to pod 3, review version 3 pod, it's going to show a red star ratings. Okay, so first of all, see, as of now we have not at all implemented any service mesh. So how traffic will be going here? So all these three pods traffic will be going equivalent. That means key first, if three users are sending a request, so first time it might go here, second time it might go here, third time it might go here. That means the user will first see reviews without any rating. Second time he will see reviews with black star rating. Third time it will see reviews with red star ratings. Okay, so here we are not at all controlling any traffic as of now. Equal times it will be going. Three times someone is sending a request, 111, it will go like that. Okay, then comes the service mesh. How exactly it works, let me show you. So for that also, let me take one diagram so that it's much easier for you to understand. Okay, before I paste the diagram and explain it, let me explain you one very important concept of container: sidecar container and init container. Okay, two containers we have: sidecar container and init container. Sidecar was the one that we are going to use now, but still I'm going to explain both of them. Let us say this is our pod. Let's call it as P1. So inside the pod, as you know, there will be our application container. Let's call it C1. So generally we have seen that inside a pod, one container exists, but as you know, inside one pod, we can have multiple containers as well. So let me explain you the scenario where we'll be having multiple containers. First scenario where we have one container. This is going to be init container. Why init? Because let's say this container, C1 container, is of MySQL. Okay, so this container, second container that we have, C2, we are going to be using a, let's say, Alpine based container, whose task is to check if this container, the MySQL inside that container, it is running or not. It will execute some command, it will try to log in, and it will check if it is running or not. So main task of this container, container 2, is to check or set up some environment, okay, for the first container. So once container 2 has said ki, okay, container 1, which is the MySQL container, if it is running fine, then container 2 will say ki, okay, my task is done, and it will be removed or destroyed. This is init containers, which exist for very short period of time, which is supposed to perform a small task. Once its task is completed, it's going to get removed. That is going to be init containers. Second kind of containers that we can have inside pod is known as sidecar container. What are sidecar container? Let me explain you that as well. Let's say this is my C1 container, and let's say this is MySQL container. So this time the second container that we have, it is supposed to be, let's say we are using a file beat container, whose task is to continuously fetch the logs of the MySQL container. Okay, and one more thing you should know, ki when you have two containers inside one pod, they will be acting like local host. they will be having, they will be like they will seem like they are two services inside one machine. Okay, that means they can communicate with each other over localhost. Okay, so this container is supposed to fetch logs from the container one, and as you can see these logs are supposed to be analyzed, right? That means we will be this container 2 will be continuously monitoring MySQL. That means it is running for as long as our application runs, right? Init containers, it got removed after its task got completed, but sidecar containers will be running continuously as long, because they have to perform something continuously, so they won't get removed. Okay, so this is the basic information about sidecar and init containers. Now let me explain you with a proper example how exactly service mesh will work. So I have taken this example and let me explain you. Okay, so when we set up service mesh, what is going to happen? Let's say this is my pod. Let's say pod one. Let's say this is product page pod, right? Inside this product page pod, now there will be two containers. One container, which is the product page container. Second container will be a sidecar container. We call it as envoy. Okay. Now, when you use service mesh and you define okay, I'm going to be using service mesh with Istio on this project, then whatever pod exists inside that project, every single pod will be having two containers. Okay, two containers. Second container will be a sidecar container, that is envoy proxy container, whose task is to handle the traffic. Okay, that means let's say this is product page and let's say this is details pod. Okay, let me explain you with example what exactly is going to happen. See, previously what was happening, let's say this is my pod 1, this is service 1, this is pod 2, this is service 2. If pod 1 want to communicate with pod 2, it will send request here and that request will be forwarded to pod 2 and communication will happen. But when we use service mesh, so inside each pod there will be one extra container created, the sidecar container. Okay, and now what is going to happen, let me explain you. Let's say this is container and this is envoy and this is service 1 and service 2. Now if product page, this pod needs to communicate with this details page, what is going to happen, pod by default pod is supposed to send the request to service, but here whatever request is coming or going outside this pod for this container, it will be first going to here invoice sidecar container, because it is the one, this sidecar container is going to be the one who is going to control the traffic. That means if pod 1 need to communicate with pod 2, let's say container send the request, so this request goes to invoice sidecar container, and from here it will be going to service. Okay, and from here again service need to forward the request to pod to the container. So when service forward the request, it first goes to invoice sidecar container of pod 2. Okay, because again as I say, these sidecar containers will be the one who is managing the traffic, who's controlling the complete traffic. Okay, so this is one of the difference, and same thing you'll be able to see here, that for each of the pods, all of them are having one sidecar container created for themselves. And you can see the traffic also, when traffic is going, it's not going directly to the pod, it's going first to the uh, see, for example, if product page needs to communicate with these reviews or the details pod, they are going to send the this container will send the request to this invoice sidecar container, and then it's going to forward the request to the sidecar containers of them. Okay, that is how traffic will be managed. And again, this is one of the most important thing, envoy proxy sidecar container, it is the one that is going to handle the traffic and manage the complete traffic. Okay, now, so we understood this thing, this is sidecar container who's going to manage everything, and it's like this. See, previously we had structure like this: pod 1 service 1, pod 2 service 2. This time how it will be there will be, let's say, this is pod 1, container 1 will be connected to the sidecar 1, which connect to the service. Then again, container 2, sidecar 2 will be connected to this. And every traffic that is going to the application container, it is going through the sidecar container only. Okay, because again I said ki encryption needs to happen. That means if these two pods need to communicate with each other, at both the ends encryption is going to be happening. Okay, okay, so now what we can do, we can implement this project. So cluster has been created, we need to configure few things and then we can start. So cluster has been created. Next thing that we need to do is install kubectl and set up the kubeconfig file so that communication can happen. We can communicate with the cluster. So for creating the kubeconfig file, you can run the AWS CLI command to set up the kubeconfig. And then we are going to install kubectl so that we can communicate with the cluster. Okay. And one more thing that we are going to do is install EKSCTL. So what I want to do, in case we plan to deploy any like persistent volume based project, so for that purpose we will be needing to create a service account which is going to manage the EBS volumes. Okay, so for that service account we are going to create using EKSCTL. So for that I have installed EKSCTL. Next thing I'm going to install, we are going to set up this, we are going to associate the IAM OIDC provider so that the resources inside Kubernetes cluster, they can assume IAM roles. So if any requirement is there to create volumes, so that can be done. Okay. And then we are going to create this service account using EKSCTL via cloud formation so that, so you can see this is the service account which is going to have a policy attached to itself, Amazon EBS CSI driver policy. And this service account is the one who's going to manage the volumes. Okay, so this will take a little bit of time. And after that, the three things we are going to install. Even though we are not going to use the ingress controller or sort manager as of now, but still I prefer to install it so that we are clear, okay, these are the default things that we need to set up. Okay, so let's wait for this to complete. Yes, we can use service mesh with the Istio in blue-green deployment as well. We can use that. Okay. So from our side, Kubernetes cluster has been set up and we can confirm the same. Let's wait for this. By running the command kubectl get nodes. Okay, you can see we have installed version 1.32.3. EKS cluster is set up with 3 worker nodes. Talking about next step. So next step, what we have to do, we have to set up Istio. Okay. So for that, we can execute these 3 commands, which is going to install Istio and export the path as well. So let me run and let's see. Okay. Now, once we execute this command, what is going to happen? It creates a new folder. Okay. The demo application that we want to use, it will be existing on this folder. This, see, as soon as previously we were on this folder, Mega Terraform project. When we installed Istio, it created one new folder with the sample code inside it. This is the folder. So our demo project exists inside this folder, okay, which we are going to be using today. So what we have done now, we have installed Istio CTL so that we can communicate. Next thing we have to install is the profile. We need to set up the Istio profile. Why we need to set up? Because there are different profiles available. Some are like profile like demo, profile like remote, and there are different profiles available with different functionalities. Basic difference between these profiles is that, for example, you want to just learn Istio, understand how exactly it works, you can go with demo. So certain features will be pre-built and available by default inside demo profile. If you want production grade, you want to use different profile. Okay, so based on that, you can decide which profile you want to use. So for now, we are going with demo profile. You can set up in this format, and let's see. So basically, it's going to deploy a few things now. Need of OIDC provider. So Raj, basically, inside Kubernetes cluster, for example, let's say that there is a this pod is available, and pod requires the creation of volumes. So in case we are using like EBS volume, so how your pod will be able to create the volume on AWS account, right? So we need to enable that. We need to set up permission so that they can assume IAM role, and using that role, pod a volume can be created. So for that we need to have that. Okay, so this is done, and now basically let me show you. When we set up the profile, there are a few deployments that are already created. Let me show you a few of them. kubectl get all -n stio -system. So basically what happens, there will be a namespace got created, Istio-system, inside which few things will be there. First pod we have egress gateway, okay, which is a pod which is supposed to manage the outgoing traffic. Then we have Istio ingress gateway. So whatever external traffic comes, it will be coming to this pod. Okay, this is ingress gateway. This is going to handle the traffic. Okay, coming to next thing. So Istio we have set up. Okay. Next thing that we want to do is create a web space. We create a namespace inside which we are going to perform all the deployments. So I can create the namespace named web apps. Okay. Next thing that we want to do, as I told you, we are going to be having sidecar containers. So I'm going to tell that for this namespace, make sure that whatever pod gets created inside this namespace, they should be having the sidecar container. Okay. Istio sidecar container. So we will run that as well. This is done. Next thing that we have to do, the application that I explained you, this application, we have to deploy this application. How we can deploy? So as I told you, here, if I show you this, the samples folders that you see, it is having the code for the demo application. Also, this same code will be available over GitHub. If I show you GitHub, Istio, see here you have this, where is it? Samples. Inside this sample folder, we'll be having different files for Istio that we'll be using. For example, where we have this file, Bookinfo platform cube Bookinfo YAML. Bookinfo platform cube. This YAML file that you see, it has defined what things we are going to create. Okay, so let me show you what exactly things are we are creating. First and most important thing, deployment. As I told you, how many pods we are going to we are going to be creating. One pod for product page, one pod for details, one pod for ratings, and 3 pods for reviews. And remember that these 3 pods will be connected to the same service. So that's what we have to create here. And that is what is defined in this file. We are creating 3 pods. That means we are going to be writing, if you see here, deployment ratings version 1. Same thing will be able to see here. Where is it? Deployment reviews version 2. Okay, so like this we'll be having 3 pods for reviews, 3 different versions of those pods. So now we can perform the deployment. You can execute this command, which is automatically going to fetch this file and deploy it. As I told you, inside this file, that samples folder is present. Inside that we have those YAML files. So we can execute this, and these deployments got created. And now we can verify this as well. We can execute kubectl get all -n web apps. Okay, you can see pod initializing, so it's in process of coming into online. And here you can see the status ready. Ready means by 2 means there will be 2 containers. Okay, so let's wait for this. Again, this will take a little bit of time to come into running state. Okay, so these are running. Okay, and as of now, we have not written anything to access the application, because by default you can see all the service type are of load balancer type. That means as of now we won't be able to access application from external. And as you remember, I told you ki when we deploy the application, when we set up the Istio or demo profile, ingress gateway got Istio ingress gateway got created. Okay, that is going to manage the external traffic. Okay, talking about how exactly we can access our application from outside. So first thing, ingress gateway is already created, that is going to manage the external traffic. Other than that, we have to create two more resources. One we have to create, which is gateway. Second we have to create, which is virtual service. So gateway, what it says to ingress key, you are already accepting you can accept traffic from external, and you listen for specific host names. Okay, for example, this for so we will be creating a resource named gateway. Inside that we are going to write specific URL. Okay, specific URL means xyz.com, and we tell to ingress gateway ki if any hit comes on the xyz.com, you send it to me. Okay, that's what we do. And then we have virtual service, where we say that ki whatever request is coming to gateway resource, that resource will be coming to me, and I will decide ki where exactly this request is supposed to be forwarded. If I show you the example content, this is gateway resource. Also, Tim, if you want to know like this thing API version, how do we find ki what will be the API version of gateway? Because gateway is like a by default it's not available, right? So here what you can do, you can run command like this, kubectl explain gateway, and here you'll be able to see what you need to write in API version, this slash this. Okay, so if you see any resource that you are not aware about, you can get the API version of that resource by running the explain command. So what we do here, we create one gateway resource. Okay, and here we define ki this gateway will be managed by this gateway will be connected to this Istio ingress gateway. Okay, and here we define host. So as of now, since we are not using any custom domain, so we can write star. If you have any custom domain, you can simply write the URL that domain like xyz.com. That means ki whenever uh, uh, this ingress gateway receives a hit on that specific URL, it will be forwarded to gateway. Okay, since we are not using as of now, so we will be writing this. Secondly, we create virtual service, where we define that request coming on this specific host, that will be forwarded to that is coming from Bookinfo gateway, and it is supposed to be forwarded here. If URL matches this, see in URL if you write slash product page, it will be forwarded to product page. Okay, that microservice which is the home page of our application. So let us create these two resources as well quickly. Okay, again, see team, these two files that you see here, they are also available on this location, Bookinfo networking. Let me show you. Bookinfo networking gateway.yaml. Here these files are already present. If you are using any specific host, that you can modify. As of now it's star only. If you have custom domain, that you can directly modify. So we can, this will make sure that our application is accessible over browser. So we will execute this as well, creating these resources, gateway and virtual service. Virtual service decides where exactly traffic will be going. So let us execute this as well, and these also got created. Now what we have to do, we have to get the service URL using which we can access the application over browser. So you can get the SVC, you can get the service, you can get the service of what? If I show you kubectl get all hyphen n istio system. Sorry, it should be small. Spelling mistake. Okay. So this URL that you see, using this, we can access the application. Okay. If you want to just don't want to go into inside the specific namespace, you can simply execute this command to just fetch the external IP of this ingress gateway. So we can execute this. Let me get the URL. So now this is the URL where we can access the application over browser. So let us try. I can put this slash, as you remember, in path based we defined product page. Product page. Now this might take a little bit of time to come into running state because we just created. Okay, so it is running. So this is the home page of the book application that we just deployed. And now here, details you see here, which is coming from the details pod. And then we have reviews. These are the reviews. And 3 pods we had for reviews, right? 1 pod, no rating. 1 pod, red star rating. 1 pod, black star rating. Now, if I refresh the page, you can see as of now we have red star rating. If I refresh the page multiple times, sorry, see, ratings now gone, no star is there, correct? Again refresh, black star rating. Again refresh, rating gone, red star rating. So like equivalent amount of like traffic is going on all 3 pods. You can see that because we have not defined key how much traffic will be going to which specific pod. We have not at all defined that. Okay, so this is happening. Now what we can do, we can define traffic. But before that, one more thing, team, I should tell you about mTLS. I told you ki encryption is going to be happening whenever communication happens inside the cluster among the different microservices. Both the points, encryption should be there, right? So by default, the way that Kubernetes will work, it will accept the traffic that is encrypted plus that is not encrypted, both of them. It's going to be accepting both of them. Okay, so our requirement is that if both kind of traffic is coming, we should be making sure that only encrypted traffic should be accepted. Non-encrypted traffic should not be accepted. So for that, what we do, we set up a condition where we define key this peer authentication should be done with mTLS with mode strict. That means key only the encrypted communication should be allowed. Okay, so what we can do, we can create this file. See, these are the options that by default in default Kubernetes we don't get, and we get these options available very easily using service mesh if you are deploying using Istio. So we can deploy this. Okay, it is done. We can verify also using running the describe peer authentication command. And if you see mode strict, then we can confirm key okay, it is fine. You can see the mode is strict. That means key now only encrypted traffic will be allowed inside Kubernetes cluster. Okay, this is done. Okay, now as I told key inside service mesh, when we deploy application using when we use service mesh with Istio inside cluster, we had one option for monitoring the traffic also, right? For that we can deploy something more. Okay, okay, team, before that, just to let you know, our batch 10 will be starting from 15th of June. If you're interested, you can enroll. Best part is that, first of all, this is going to be a recorded batch with 24/7 doubt support via Discord server. So from 15th itself, the thing is you'll be having complete access over the content. Talking about the content, so this is not just basic projects. We are going to be implementing around 20 plus real world projects that are corporate level. For example, this is my previous batch Kubernetes module. In Kubernetes module itself, we had 25 plus hours of content. Project one, which will help you understand how exactly to write the code. Then we have first capstone project where we have integrated every single tool that we study. Then we have Helm charts. Helm chart also, I will teach you how to write the charts, not just copy paste, but to write the chart. Then we have GitOps, HashiCorp, Prod Vault. In HashiCorp Vault also we have two versions, Dev Vault and Prod Vault. So on production, how we can set up the highly available HashiCorp Vault, that is there. Then This project number 6, we have user managed database. If you are deploying an application which is using other kind of database, for example database is on AWS, the managed database like AWS RDS, so how do we integrate it with our application using external service? Okay, then GitHub Actions project that is going to deploy the application over EKS cluster. Okay, blue green deployment, two examples I have given for blue green. Then we have microservice project, then canary deployment also I have shown how exactly you can implement it. Highly available cluster, rollback, auto scaling, networking, RBAC, tents, ingress in detail. Then we have stateful set also in another level I have covered actually, service mesh also, and understanding corporate projects and day-to-day activities for a DevOps engineer. Again, team, from 15th itself, you can connect to me one-to-one if you are already preparing and if you want to know what kind of project you should be adding in your resume. So these are first set of projects. Other set of project, if I show you in Docker, let me show you. If you see here, Node.js plus MySQL, .NET plus MongoDB, Python plus Postgres, and Java plus MySQL. So basically, you'll be having knowledge on writing multi-stage Docker file for all these examples, all these kind of projects. Okay, and in this way, once you execute all kind of project, you have enough knowledge using which you can answer very easily in your interview. So again, the discount that we have that will be valid till 15th only. After 15th, the discount will be gone. If interested, make sure to enroll. Okay, coming back here, team. Now, what we can do, we can set up observability so that we can monitor the traffic. Okay. Again, for that, we have sample files. If I show you the sample files, add-ons. Okay. So these files that see Grafana, Jaeger, Kiali, Loki, Prometheus, these are the monitoring tools that are going to monitor different aspects. So we can deploy all of them. And the thing is, this application that I'm showing you guys, this is a demo application that you can use very easily and use this application as the base for your own application. So you can modify few things inside these YAMLs and you can deploy your own application. So now we are going to deploy this so that we can monitor the traffic also. Okay. So as I said, this file is this monitoring task is available inside this folder. So I will copy this, paste it here, and let's see. So all these resources, the monitoring resources are also deployed. But the thing is, if I show you again, kubectl get all -n istio -system. You see, we do have deployed these things, Grafana and everything, but as of now none of them are accessible over browser because all of the service type is cluster IP only. And if you have cluster IP service type, by default you won't be able to access the application outside the cluster, right? So what we want to do, we want to change this cluster IP for specific resources so that we can access them over browser. Okay, so for that what we can do, we can run the patch command, which is going to convert those cluster IP service type to load balancer service type. So we can execute this as well. Uh, and I'm doing this for Kiali, Grafana, Prometheus, and tracing. So let me show you. You can see these resources are patched. Okay. Now, once this is done, what we can do, we can access this over browser. So let me show you. We can get the services. Okay. So let us connect to Grafana first of all, running on port 3000. Again, we just converted, so it might take a little bit of time to come into running state. Still, I will provide the IP URLs. This is Kiali, which will be running on port 20001. Okay, it is running. You can select the namespace and traffic graph. Okay, and let's see for this. Prometheus we can connect, which is will be on 9090 port. And in status you can go on target health, so you'll be able to find from here what things are being targeted for monitoring. Okay, let me check for Grafana as well. It should be running by default on port 3000. Okay, and by default we can sign in. Default username will be admin. We can set up new password. Okay, and you can see by default one dashboard is also present, multiple dashboard actually. Okay, so yeah, we will leave this as it is, and we can now go to next part of our deployment. Okay, now we come to traffic management. Now let us say that my requirement is that let's say I want to manage traffic. So my requirement is that, let's say, uh, in our application, the reviews page that we had, it has 3 pods, correct? Version 1, version 2, version 3. Okay, and it has service. These pods are connected to the same service. Okay, on version 1 we have set up the condition, the Docker image that we are using, it is having specific condition that says ki no stars. For ratings, no stars will be showing. For version 2, ratings, red stars. Version 3, black stars. Okay, and we have one more pod which is for ratings. Okay, now my requirement is that let's say if around 100 people are trying to access my website, I want that key around let's say key 50% should be seeing black stars, 50% should be seeing red stars, and 0% should be seeing 0 stars. Again, if required, if required, we can change this. Let's say I set up the condition 100% on no star, and on these things 0%. Okay, so it's completely up to us how what we require. So let us implement this. And for implementing this thing, what we need, two things we'll be needing: destination rule and virtual service. In destination rule, we define very clearly that we have 3 pods which should be treated individually. Those are 3 different pods that should be treated individually. So for that we have to create subsets. It will be like we are creating group of pod. And how do we differentiate them? So you can see here version v1 and name v1. From where this is coming, if I show you directly, samples, Bookinfo, platform cube, we had this bookinfo.yaml. Here, reviews, you see reviews version 1. So here in label, we have added version v1, which is going to be utilized for individually identifying the pods. And that's why we have added it here, so that we can clearly set up a subset for each of the pods. Okay, so once you create this, once you create the destination rule, we define very clearly that traffic should be going where. So for going where, we have 3 options that we are defining here. Host is reviews, key mean we are talking about reviews pods. So inside that we had 3 individual pods that are different, that we have defined here. Second thing that we define using virtual service is how much traffic should be going to where. Okay, for example, here you can see key I have written on subset v1 0%, subset v3 0%, subset v2 100%. Where it should be 100% means percentage of traffic. So once we define these things here, we can say now if I deploy this, we can it will automatically be all the traffic will be going to pod version 2 only. Let me show you. So first let us create destination rule. I will create ds.yaml. Sorry, it should be dr. We will save this. We will run the command kubectl apply -f dr-n web apps. So destination rule is created. Next thing that we are going to create is the virtual service, where we have defined the percentage of traffic. We are basically controlling the complete traffic. So I can create vs.yaml, and we can put inside here, and we can deploy this as well. Okay, this has been deployed. Okay, meanwhile, let me refresh this page also. We can select the webspace namespace. Okay, and now we will refresh our page. Let me see the status also. kubectl get pods and web apps. Okay, sorry, let me update the URL since we are not using HTTPS. Okay, black star. If I refresh, no matter how many times I have refreshed, you can see black stars only showing. That means ki all the traffic for reviews is going on the version v2 pod. Okay, you can see how many times I update. Every time only black star. Now let us modify this. Okay, so we will again go to vs.yaml. Here we will modify a few things. We say that ki now I want to see only red star and black star, so I will change it to 50-50 percentage to version 3 and version 2. Version 1 still 0, so that we don't want to see no star spot. So we will save this and we will deploy this. Deployed. We can go back here, refresh the page. You can see red star, black star, red star. Only two kinds of stars, like ratings we are able to see, right? Third scenario, we can see that, let's say I want to see no ratings, no stars I want to see. So for that, we can change these to 0 0, and this we can change to 1 0. That means ki now we are deploying the application so that traffic should be going to no ratings thing. One second, let me deploy these changes. Once deployed, we should be seeing the changes to take place. You can see stars gone. No matter how many times I refresh, stars will be gone. Okay, so this is how you implement service mesh, and I hope this was clear for everyone. I hope everyone understood how exactly we can implement this. And team, again I am saying, make sure to check out this batch 10. I'm showing you as of now the content of batch 9, which will be completed in few I guess coming week or so. Okay, talking about one more thing, team, for Jenkins itself, if I show you one very interesting thing, RBAC. Some of you might have heard about it. What exactly is RBAC? Rule-based access control. So when we use Jenkins in companies, we don't set up like we have to set up profile using like specific team members. For example, we have three groups: developers, DevOps engineers, and some like stakeholder. So we will decide ki what permission should be given. So we using LDAP, we can set up permission ki this group of people will be having this permission, like that. So all these things we have covered. Okay, trust me, just go through the syllabus once, you will understand what exactly are the things that we have covered. Okay, again team, starting from also team, talking about the hours of this batch 10, it will be more than 120. It will be between 120 to 150 hours. Okay, so yeah, make sure to check it out. And again, as soon as you enroll, you'll be getting access to exclusive Discord server, and you can connect to me directly one to one whenever you have any interview schedule. You can connect, or if you want resume building, and that is allowed from 15th of June itself. The day you enroll, from that you will be you can connect to me. Okay, now we can take questions, guys, if we have any questions. If you have any questions, we can take questions. Okay. Also, yeah, Tim, talking about notes, so document I have already created. So where should I upload it? Okay, so I'll share it somewhere and just make sure you are listening. I'll post the link somewhere in my Telegram group. Maybe I'll post. You can get it from there. Okay. Again, make sure to implement this. Then one day you will get a real time idea like how exactly everything is happening. In simple words, if I try to say like how exactly service mesh is beneficial for us, so in simple words, so I can say that it's basically providing us complete control over the traffic, plus making sure security is integrated or enabled not just outside but inside the cluster also, because by default when we are not using service mesh, it's like plain text, like communication will be happening via plain text, just http plain text. That is not a good option. So when we use this service mesh, it's quite useful and enables security, enables much more like monitoring option also. If I show you, I think I did not show you this one. Dashboard. Okay, let's open dashboards. So yeah, you can go to dashboard in Grafana. You'll be able to find a lot of different information, what exactly like we want to monitor. And here also, okay, let me, here also we should be able to see to which pod you can see here. Sorry. These things that you see, this version 1, version 2, version 3, you can see now traffic is directing only to version 1. Okay, so here also proper information we can get about the traffics. Okay guys, so yeah, now if you have any questions you can ask me. And GitHub link, Ramesh, GitHub link won't be useful because the only thing that I used from GitHub was the Terraform code that is available for public, like it is public repository. You can directly refer it. Anyway, I said na ki in my Telegram group, I'll be posting the document itself. From there, you can download and you can use it. Okay. Any other question, guys? If you have, you can ask. Also, my course details, it is already added in comment section. Whoever wants to check, you can check it. Rest, if you want any information over call about the course, you can connect over WhatsApp. My team will be connecting you. Gateway API, maybe in future I'll try to cover. Okay, also team, yeah, I have planned to cover this one, candidate deployment strategy also with demo, so you can understand how exactly it happens. If you want, just let me know. Okay, any other question, guys? If you have, you can ask me, or we can close the session for today. I hope this was useful and you got to learn something. Okay, guys. So thank you so much for joining and have a nice day. Any queries, you can direct to my Telegram group. You can check out the Telegram group for a document. And for course related queries, you can connect over my WhatsApp. I'm pasting the contact also here. Troubleshooting tips, basically, see, directly we cannot say, because once we start the implementation, so there when you see the problem, there you will see ki, okay, based on this problem we can decide ki what exactly we have to do. So before itself I won't be able to say ki what troubleshooting we should be doing. Again, troubleshooting, in any location, any place, wherever it is required that we have to do troubleshooting, the way that we have to do troubleshooting is that ki based on logs, whatever logs we see, based on that we decide ki, okay, what we have to do. Other Kubernetes resources extended like Istio, there are many actually. I'll try to cover few of them in coming days. Okay, any interesting question, guys? If you have, you can ask me. And again, for those who are already in the batch, if you are interested, you can just connect from 15 itself. You can connect to me for interview preparation, what projects you should be adding in your resume. Those things you can discuss with me. Okay. Okay, guys. So I guess that will be all for today. And Naveen, 1 second. Let me share my Telegram link. Just I have pasted my Telegram channel link. You can join here. I'll be posting the document here itself. You can directly download it. Because from here, I don't see any option that I can actually share you directly from here. So I'll just share in that. You can download it from here. Okay. Yes. So as compared to the ingress that we use and in ingress gateway that we use within Istio, Istio version is having much more advanced features. Okay, there are much more because one of the one interesting example that I can tell you, the default ingress, the one that we use without service mesh, it is supports HTTP and HTTPS mainly, while the one that we have with Istio, it supports many other things, gRPC, HTTPS, HTTP, and many other also it supports. So in simple way, I'll multi-cluster management course. Separate course is not there, Satya, but in my batch, I'll be adding one project where I'll be showing multi cluster deployment. If you have like one cluster on AKS, one cluster on there, or if you have some resources in one cluster and some resources in other cluster, how we can perform deployment, that I'll be showing you. See, this question that you're asking, main difference between service mesh and Istio, it not exactly the correct question, I would say. Istio is something that Istio, you can say it's implementation of service mesh. Like if you want to use the that whole concept of service mesh inside your cluster, using Istio, you can implement that. Istio, you can say it's implementation of service mesh. Okay. Okay, guys, I'll share the document. You can just start implementation. If any doubts, you can just ping me. Okay, and again, make sure to check out the course details. Whatever you have doubts, you can just ping me on WhatsApp. We'll connect. Okay, so yeah, thanks for watching, guys, and have a nice day. And by day after tomorrow, probably I'll be showing candidate deployment, how we can implement it with demo. Or one example I'll show you. I have some pictures that actually I implemented a few days ago. Let me show you. My screen visible. You see this example. This was done using Argo rollout, where candidate deployment I was doing. This is revision 2. This is the second version, and this is version 1. As of now, you can see 4 pods here, new pod getting created, and after some time, you can see now we have 2 pods here and version 1, 2 pods here, version 2. Okay, what exactly is happening here? Testing is being done on version 2. I said ki small traffic is started first. For example, like we have one pod here, that means ki 20% of traffic we are sending to version 2, while rest of the traffic is going to version 1. But when after some time, after we have performed our testing, whatever testing we want to do on new version, after that we increase the weight, we increase the percentage traffic, 50% on the newer version 2 and 50% on the version 1. And finally, when everything is fine, we shifted our application complete 100% traffic to version 2. Okay, this is what I have implemented, I think day before yesterday or so. I'll be showing. Okay, what will be the batch class time like on weekends or weekdays? uh Adrija Basu, batch 9, I wouldn't recommend to enroll because it is completing, and batch 10 will be having complete batch 9 plus more contents and more projects, plus separate dedicated support will be there so that you can immediately connect to me if you are facing any issues. So better to go, if you want to, if you are if interested, better to go with batch 10. And batch time is going to be a recorded batch so that immediately you can start implementing everything. Whenever you face doubt, you can come to me over Discord server. Okay. Argo CD, I can do that, but again, I'm these days little bit occupied, bro, because I'm like adding more and more content over batch 10. So cannot say for sure, but canary deployment I'll be showing probably after day after tomorrow. Okay. Okay, guys. So I'll close the session for today, and thanks for watching. Have a nice day, everyone.